Hello everyone, welcome to my channel. So today's topic is that how to make a polymer or a monomer of a given molecule. So before that I would be teaching you how to write a monomer and how to make a polymer. So first I will go on to monomers. So whenever you are making a molecule of a monomer, just make sure that the monomers are the ones that mono means single molecules. So whenever you are making a monomer, what you need to do is you just need to make a single molecule. Therefore, what you do is, for example, if I am making a monomer of any molecule which is given to me, so this would be the molecule, and I don't put any dashes here. So this dashes should not be put, because when you put this dashes, it basically implies that your monomer which you have drawn, it is continuous. Okay, so when you make this dashes, you basically mean that your monomer which is there, it's continuous. So when I would be making a polymer, okay, you have to remember that they should have a dash that should be continuous. So here I am drawing a polymer. So this is how you make a polymer. These dashes which are there, it is there to show that there would be, this is continued as the repeating units. Okay, so saying goes for this, that here the dash basically implies that at both the ends this polymer is continued with the same repeating unit. Okay, so always remember that whenever you're making a monomer, just make a single molecule. Whenever you're making a polymer, this dashes should be there to say that this is continued, and this n represents that there are n number of this repeating units. Okay, so now we would be going to see how our polymers made and what are the essential things which you need to do. So let's get into that topic quickly. We all know that the polymers which are there, they could be made by two processes, that is addition polymerization and condensation polymerization. So I'll be just writing here addition polymerization and condensation. So always remember, whenever you are drawing a monomer for addition polymerization, it is very important that it should have a double bond. Okay, so this is very important, and it should always have a double bond whenever you're drawing an polymer made through addition polymerization. And second point, that there will be only one molecule used to make the polymer through the monomer. So whenever you're told to make a monomer from a polymer, just remember that your monomer should have double bonds, and the second thing is it should be just one molecule. It's not possible to have two molecules through when you're making addition polymer. If there are two molecules, it would be probably a condensation polymerization, but not addition polymerization. So now we will talk about what happens if you are told to make a monomer. So in condensation polymer, you have to add water to your molecule or HCl. So if they say you to hydrolyze the polymer, they basically mean that they want you to add water to the given molecules, and in this case there would be more than, so it could be one molecule or two molecules present. So this was for monomer. So if they ask you to make a monomer from the polymer given. Now if you would be asked to make a polymer from the monomer given, the things that you need to remember is that the breakage which happens, it happens from the double bond. So the breaking of bond happens, it happens from the double bond, and therefore you should just be keeping that as the double bond and nothing else. And you should also remember that the repeating units should only have two carbon atoms present. So it's not a possibility that you have more than two carbon atoms present in the repeating unit. It would be surely just two, remember. So this one is a very important point. So when we come to polymerization of addition polymer. Now we will talk about polymer. If you are told to make a polymer from the monomers, so most probably you have to remove a substance. So it could be water. So you have to remove H2O. So H2O is removed in this from both the molecules, or if it's a single molecule, and in here you would be having linkages. So if you have linkage present, like ester linkage is present, or has an amide linkage present, or it could have glycosidic linkage. So in ester linkage, you would be always seeing that you have this thing present, that is C is double bonded to O and O. When it's an amide, you would see it has C double bond O NH. And in the case of glycosidic linkage, you would have a linkage present as O dash O. So this glycosidic linkage is most probably present in the starch or carbohydrate which is there. When you talk about amides, this linkage is present in nylon and proteins, and when you talk about ester, it's present in pterylene. So we would just see both of them separately, so we could understand it nicely. So now we'll go on to the topic for to see how you could make a polymer of a monomer which is made from addition polymerization. Alright, this here is an polymer which is made through the addition polymerization. So now we'll see how would you make a monomer from this polymer given to us. Okay, so whenever this here is an example of addition polymer, we could say this by looking at this molecule, because it has this continuous CC bonds. So whenever there is like continuous CC bonds present, it just means that it's made through an addition polymer. If it would be made from condensation, it would have linkages rather than the CC bonds which is present. So in the case of addition polymerization, you will be having a repeating unit which would consist of two carbons present. Okay, so in this we would see which is the repeating unit. So this here which I am drawing into boxes is a repeating unit itself. Okay, so I would write that down here. Okay, so in this I have written the molecule which is exactly here. So whenever they have told you to make a monomer, the first thing is you just copy whatever the molecule is, but you don't put the dashes, simply because this dashes means that the molecule is continuous. So as I told you earlier, whenever you're making a monomer from a polymer made through addition polymerization, you would be always having double bonds, and the double bonds would be present here. So therefore, the double bonds would be always present in a linear way, which I am drawing here. And that's it. This would be your monomer for the specific polymer which is given to you. Okay. So here it could be a one more possibility, like most of the students would think. You could also write as this. But this would be a wrong one. It should be always seen that the fluorine and chlorine should be on properly kept on both the atoms. So you could change the position of fluorine and hydrogen, that's okay, but you could not change the position to a different carbon atom, because if you do that, then this which is there, it would be to a totally different polymer. So you have to remember that this here, the chlorine and fluorine, should be on the different carbon atoms whichever they are placed properly. Okay, so now we'll see one more example regarding it. So now in this example, we go again see. So this here is a polymer, and the repeating unit which is present, it's this. It consists of two carbon atoms. So what we do is simply take the one that is a repeating unit and write it down here without the dashes, and the rest everything would be same as it is written in the polymer. After writing this, what we need to do is just add the double bond, and that's it, your monomer is made. So this is when you would be asked to make a monomer from the polymer given. Now you will be seeing how to make a monomer or into polymer for a given example. So this here is propene, okay, and the name of for the polymer made for this would be polypropene. So if you don't know how I have written this, you could check my previous video. You could get the link in the description. Okay, so now this here is propene, and you would be getting polypropene as the name of the polymer. So how do you make this as a polymer? So I have some steps that would help you to easily make your polymer for this type of polymer. So here this is an example that this polymer would be surely made through the process of addition polymerization. So here what we would do first is we would just rearrange this molecule, as in that the carbon bonds which are there, they are linearly placed, and rest everything is placed upside down. So here since there are two hydrogens, I will be putting here two hydrogens. Here since it's one hydrogen, I put it one, and here there's one carbon, so I will be putting it down here. So once this rearrangement is done, after that what you need to do is simply remove the double bonds and extend this bond and put an end. So this molecule which is there, the monomer, if you want to convert this to polymer, it would be simply written as like this. Okay, so remove the double bond, convert into the single bond, and make brackets and end. So this dash, it means that this thing is continuously bonded to something, and the n here, it's a repeating unit of this present. Okay, so now it's very important to see that whatever repeating units which I would be making, it would have only two carbon atoms. So you could not write this as CH3 dash CH dash CH2 and not make this as a polymer. This would be totally wrong. You have to remember that the breakage of bonds always takes from here, that is from the double bond, and so the binding would also happen between these two carbon atoms only, and so you would be having just two carbon atoms in the repeating unit. Okay, so this here is very important to understand that the double bond would break, and therefore the repeating units which you would be having, it would be also two carbon atoms. So we would see one more example so we could understand this nicely. Okay, so here we would take a molecule that is chloroethene. So this would be the name of the monomer, and the name of the polymer would be polychloroethene. So we would just follow the same steps. That is, we would be writing down this molecule linearly. That is, the carbon atoms which are placed, that is this double bond, we'll place it linearly, and then we'll just place everything which is around it up and down. So since this carbon atom has two hydrogens, I'm placing one up and one down, and same goes for this. So this, after rearranging this molecule, the next step that you do is just remove the double bond, add the dashes to the carbon atom and the bracket. And don't forget to put n, because n is very important. It tells us what is the number of it. The number of repeating units here is n, that is infinite or continuous. Okay. So now we'll see a molecule. There would be two isomers, and the isomers would have different structure of polymer made. So we'll see that how it's done. Alright, so now we have taken two different isomers, and we'll see their structures of polymer respectively. So in this we will be again following the same steps. That is, first we'll put the carbon atoms which is here linearly. So it would be written as this, that is carbon carbon. Now we would see on the left hand side there is one carbon atom, that is one methyl group present. So that I would be writing it here. So you can put this methyl on the top or the bottom, wherever you feel. I've just written it at the bottom. So you could also put the CH3 at the top, but you should be just sure that since there is one methyl group present, so just put one here. So it won't be called as a methyl substitute because it's in the chain, but here since I'm just putting it here. And same goes for the one which is at the right. Since it has one CH3 attached to it, you will be writing it as this. So this would be the rearrangement of the molecule. After doing that, the next thing that you will be doing is removing the double bond and putting the dashes, and So this would be the polymer made from the but1ene. Now you would be seeing what would be an polymer made from but2ene. So the same steps we follow. We write the double bonds linearly. So to the right hand side, there is no carbon atoms present. There is a hydrogen, that has two hydrogens. So you would write that. And at this end, okay, you could see at this end there are two methyl groups present. Okay, so this methyl groups which are there, you could not write it like this. Okay, so you can't keep one methyl group at the top and one methyl group at the bottom. No, because since both of them are in the straight chain, therefore you have to place them in the straight chain accordingly. So if you write in this manner, your rearrangement would be wrong. Okay, therefore you will write it as this manner. So it should be in a straight line, continuous line together without any. So this would how you can write this, or you could also rearrange it by writing it like. So both would be accepted. So the carbon and hydrogen have combined together and written it here. That's what I have done. So after doing this, your last step would be that just remove the double bonds and put it into the single bond. This would be same. This and this basically are same, but your making this thing would be kind of tedious. So we just combine it and write it together. So here in this case, you would see that it's written like. So both could be correct. You could write whichever you want, but just in this I have taken it separately, the carbon groups which are there. Then this I have combined it together. Okay. So now I hope you would be able to understand how to write a polymer or a monomer, which is made from addition polymerization. Now we'll move on to how to write a polymer and monomer if it's made through condensation polymerization. So before going through on the condensation polymer, we will be talking about a concept that is hydrolysis. So they would be asking you that what would be the product if you hydrolyze a certain molecule. So first you need to understand what is hydrolysis here. So hydro here means water and lysis means breaking. So when they would be talking about hydrolysis, they would be just telling you to break the molecule with the help of water. So consider if they have given any molecule to you and they had told you to hydrolyze that molecule, you would be simply adding the water to that molecule. So here the water would be added to the molecule like this. Okay. So now we would be going on to the condensation polymer and see some examples regarding it. So we would be seeing some examples in which you would be first making the polymer from the monomer and vice versa. So the questions which would be related to condensation polymerization would be that they would be giving you glucose molecule, and uh, to the glucose molecule you have to make a polymer for glucose, that would be starch. So they would be asking you questions such as make the more complex carbohydrate form using glucose molecule. So in such cases you just have to make the polymer for glucose, that would be starch. The second question they could ask you is about making a polymer related to protein or nylon. So whenever you would be having a polymer asked to make regarding protein or nylon, you just need to remember that the protein and nylon both have similar linkages, that is amide linkage, and this is how amide linkage looks like. So keeping that in mind, we have to make polymers regarding both of these. And the last would be polyester linkage. So they would be giving you an example like terylene. and they would be asking you to make how would be the polymer of terylene look like. So whenever it's a terylene, you need to remember that there would be an ester linkage, and in the case of ester linkage, this is the structure or the linkage that you should remember. So here it could be written also as this. It's not that also right, and same goes for this. So you just need to remember three linkage. So in the case of glucose here, we'll be having a glycoside linkage, which would be looking so O with the boxes. I'll be showing you this quickly, each and every example, so you would be easily able to make whatever polymer or monomer told to you. So the first example would be taking a glucose molecule, and from glucose molecule you will be converting it to the starch. So the question asked would be, you would be given a glucose molecule and they would be telling you directly convert it to the starch, or they would be asking you to convert it to the complex carbohydrate. So the complex carbohydrate is nothing but your starch. So whenever they would be asking you when the glucose being converted to starch, the first thing you always do in the case of condensation polymer is make the boxes, and these boxes indicate that there are different amount of carbon chains present that are not useful and they don't take part in the reaction, therefore they are kept in the boxes. So whenever the glucose is converted to starch, first thing, or whenever you're writing a condensation polymer made from condensation polymerization, the first thing is you make boxes. After that, as we know that in carbohydrates there is glucoside bond present, so you just add it quickly like this, and the boxes and the bracket. This is would be so this would be the polymer made made from the glucose, and the monomer would be this respectively. So now you would be seeing the next example. So here you would be seeing that what would be the products if you hydrolyze it. So as we see the question, it says hydrolysis. So hydrolysis means breaking down with the help of water. So in this molecule, what you have to do, you have to guess how many monomers you would get from a specific polymer. So if you see both of them are like they are kind of same, but there is some changes in them. So here you could see that the CONH is continuous, and here it's if you could see like they are alternating. So first is the C double bond ONH, and then it's NH, so it's kind of alternating in this. And in the upper one, if you see, it's kind of continuous. So now whenever such type of question is given to you, so what you do is first have to guess what would be the monomer. So to do that, what I do is there's a very simple way to do this. So wherever you see the linkage, so you see this amide linkage here, the amide linkage here also. So the first thing that you do is just break or draw a line here in between all of it. Okay, so draw the line in between all the amide linkage. So now you would be seeing what is the monomer here. So in this case, if you see that both of the molecules which is here, they are similar, as in they would be looking as if they are repeating it. So this here is the same formula as well as this, and this also has the same formula. So in such cases, you would be just having one monomer. So after writing this, as we know, in the monomer, since this is a condensation polymer, there would be a removal of water, and in the question itself they have told what would be the products of a given polymer on hydrolysis. So therefore we have to add water here, and water should be added in such a way that it should be H and OH. So in this case, since the amide group we have heard about, it would be NH here, and in this case it would be OH. Okay, so for this molecule we would be just having one monomer. Now we will be seeing the next example. So in this example, again you do the same steps. You would draw a line between each of the linkage. So when you draw a line, what do you see that the inside like here when you draw a line between both of these, you could see that there are just two repeating units. But in this case, if you see there are two different monomers, you could distinguish very easily. So here it has C double bond O C double, and here this would be NH and this would be again gold. So therefore, in this case, there would be two monomers. That is, the one would be this. I write it as A, and second would be this. So now again, whenever we are making condensation polymers, the monomer for condensation polymers, we have to again add the water molecule in the format of O and HO. So in this case, I would be adding OH here, since it's a carboxylic acid we have already read about. And second is I would be adding NH on both the ends, because we have already heard about the amide group. So this is how you do. So the first one would be an example of a protein. So whenever you have a protein molecule, or they ask you to draw the protein molecule, you make sure that you draw the consecutive units, because in making protein, there is just one monomer used to make protein, whereas in the case of nylon, there are consecutive or two monomers used to make the nylon, that is monomer A and B. So they would be asking you a question that what would be the products of hydrolysis like this. So I hope you could now easily answer that. So now we would be seeing few more examples so you could understand it nicely. Alright, so if you see here, again in this polymer, we would be doing the same steps to guess what would be the monomer, and we would be doing hydrolysis, that is, you will be adding water to this molecule. Okay, so again the same steps to guess what are the monomers. So in this case, I feel it would be just one single monomer. So you would do the same step, you would draw a line wherever the breakage is. So in this case, the linkage which you talk about would be an ester linkage. So I'm just breaking the molecule between of the linkage. So in this case also, if you see what you would get, that you would be just getting one repeating unit, that is O dash box dash C double bond O. Okay, so to this molecule now, this comes from the polymer. It doesn't mean that this would be the monomer. We have to add a few more things. That is the water to this molecule in a way that is H and OH. Okay, so in this case, again, as we know that I would be adding H here. So what happens if I add OH here? It would be having a OOH group, and here it would come H. So now we haven't heard about anything like OOH group. Therefore, it would be wise to place the H on this end and OH on this end. Alright, so we would be going on one more example quickly. So it would be the same polymer, but it would have a slight change. So this is the polymer given to you, and you have to do hydrolysis, that you have to add water molecule to this back. So here in this case, the first thing, draw a line between. So when you draw a line in between, you could easily guess what would be the monomer used. So when you see in this, there are two repeating units. There is just one, that is this one molecule is A, and this one is B. There is no repeating units here, as in the case of the previous one we did. Therefore, I'll be just writing it in this manner, two monomers separately. And since this is hydrolysis, I would be adding the water molecule in the form of H and OH back to both of these molecules. So as you know, whenever there is C double bond O, we usually add your OH, and this would be a carboxylic group on this end, and here you will be adding H's. Okay, so on this, both the cases I add H's, and on this add carboxylic acid. So this would be two monomers which would be used to make this polymer. Okay, so you would see now, what if that they have given us a monomer and you would be told to make the polymer. So now I would be drawing two polymers here. So whenever like there are two monomers given to, and they told us what should be the polymer. So the first thing is that sometimes here it would be mostly water, or sometimes it would be HCl. So in this case it's water. Therefore we would be removing water from here. So when you remove water, what happens is the carbon which is on the B monomer and the oxygen which is on the A monomer, they are free to join. So here, for that reason, the bonding would be this. So once you get to know that what is the linkage, so the linkage is of an ester linkage. So now, as you want to make a polymer, this is just a fusion of two molecules. So there would be thousands of A monomer and thousands of B monomer. So they will be fusing together to form a total polymer. So once you get to know what is the linkage present in between the molecule, you simply just make boxes, okay, and you put the linkage. So this would be one linkage, next it would be this, and next would be this. But make sure that whatever you draw the linkage, it should be alternate, as in first I'm drawing it C double bond O, then O double bond C, C double bond O, and O double bond C. Whenever it's there are two monomers used, and whenever there would be a one monomer used, then you have to draw continuous. I would be just showing you what this would happen. So I've taken one more example for that. So this is a monomer given to us, and we have to draw the polymer. So since there is just one monomer and it's a condensation polymer, we have to draw one more molecule very similar to this. So now again in this case there will be a removal of water molecule, so that I would be writing it here. So now this polymerization which is there, it won't stop here, because there will be one more molecule which will be coming here at this position. And same goes for this. There will be one more molecule coming at this position, and they will be again forming water. So here this is a water form. Again here is a water molecule which is formed. So in this, what do you see, that there will be a continuous chain like that, this, then there will be this, and so on. Okay. So what you saw is that whenever it's a continuous one monomer told to one monomer given to us, a polymer which would be formed would be having a continuous, you could say a continuous pattern of linkage. So in this, you would be having C double bond O N O, C double bond NO, and so on. And whenever there are two monomers used, you'll be having an alternate pattern of linkage. That is, first we'll be having this and then this. Okay. So now as we have done all this, I'll be just sharing some questions with you, so that we could solve it. So the first question they could ask you would be regarding make a structure of protein, or make a structure of nylon, or they could ask you what would be the structure of pteryline. Okay. So in the case if they ask you what would be the structure of what they would ask you what would be the structure of protein. So since we know that both of them contain the same linkage, that is amide linkage. So while in the case of proteins, the polymer which would be formed would be this, that is a continuous chain like this, because the proteins which are there, they will be having the amino acids combined together, and the box which I have one which I have drawn dashes, one I have made it blank, one I will be doing dots. So this is to indicate that there are different amino acids which are joined together, and in this box there would be different amount of carbon and functional group present. Therefore they would be different, but they just have same functional group at the beginning and the end. Therefore they join to form this whole one polymer. While in the case of nylon, there are two monomers used. So therefore the bond which, so first draw the boxes properly, and then just make the bonds alternate. So this is how it goes. So first I've drawn C double bond O, and then O double bond C, and then the vice versa. And this is how it goes. So same would be the pteryline. So since always remember that most of whenever it's a natural polymer, the natural polymer would have a single monomer used, and in the case of artificial or synthetic polymer, there would be always two monomers used to make the polymer. So in the case of pteryline, since it's a man-made or a synthetic polymer, here you would be seeing ester linkage, and therefore you would be having alternate bonding side. So first draw the boxes quickly. In the case of condensation polymer, if you don't know what are boxes, I have made a dedicated video on condensation polymer, so please go through that. So since it's a man-made polymer, it would be having two monomers used, so this is how you make it. So always remember to keep the box, to keep the brackets in. So I hope this video would be helpful for you to understand and to make different polymers and monomers for given molecules. So if you like my video, please subscribe, and you could also tell me of what topics you want. Thank you.